Welcome back. Today we're going to be talking about thermal energy and specific heat. Questions we're going to be answering is: why does linoleum in your bathroom seem cold in the winter on your feet? A conductor. Why does that happen? Well, a conductor is a material through which energy can be easily transferred as heat. An insulator is a material that transfers energy poorly. In your homework assignment, the other day it asked about sticking your hand on a wooden block and a metal block, and why did the metal block feel colder, even though they're both at room temperature? The reason is the metal block is going to absorb the heat much faster because it is a conductor, right? Again, the metal block was a conductor, so the heat flowed much faster. The wood was an example of an insulator. Well, why did the metal? Well, heat is transferred through particle collisions. We have one particle that comes along and it collides with another particle. Well, then that one collides with another particle, and so forth. Well, metals tend to conduct energy very well, and the reason that is because they allow these particles to move inside. So again, metals allow to move, particles to move, and other things such as plastic, gases, wood, they are all what we call insulators. That's why they use these on the outside of wire, because they are insulators. They don't allow particles to transmit through them. Alright, specific heat. Specific heat is the quantity of heat required to raise a unit mass of homogeneous material 1 Kelvin or 1 degree Celsius in a specified way given constant pressure and volume. So what we're talking about here is different materials. Different materials have different specific heats. We talked about that. That was the very first question on your assignment, and the example they gave was the sand in the water, and the sand heated up fast. All right. The water heats up slow. So these two objects have different specific heats. This has a low specific heat. This has a high specific heat. Low meaning it takes little energy to heat up. High meaning it takes lots or high amounts. Okay, we have an equation. Specific heat equation. There's three things that we had dealt with. Three key factors that allow us to find out how much energy is necessary to heat an object up. First is its mass. It takes a lot more energy to heat up, let's say, a gallon of water than it does a cup full of water. All right, if you stick a cup of water in a pan, it's going to boil pretty quickly. But if you try to boil a gallon of water, it's going to take a lot longer. Energy. The specific heat. It takes more energy to heat water than it does sand. It takes more energy to heat up water than it does metal. So here are two of the factors. The third factor then is the change in temperature. Right? The third factor is the change in temperature. How much do you want to change the temperature of the object? Likewise, if I only want to heat the water up a little bit, then heat stands for energy. I only need to change its temperature a little bit. So it takes less energy because I'm only heating it up a little bit. So again, the M stands for mass. The C is specific heat. Sometimes in different textbooks you'll see CP for specific heat. And then delta T means the change. The delta, the triangle, means change in temperature. Here's some specific heat values. What I want you to notice here is that water up here at the top is taking the most energy. Water takes the most to heat up, and something like lead and gold, these take the least amount of energy. So if you were to put water over a fire, and put gold and lead over the fire, in a very small amount of time, the gold and lead is going to be much hotter than what the water is. Alright, so here's some problems. How much energy must be transferred as heat to 200 kilograms of water in a bathtub to raise the water temperatures from 25 degrees Celsius to 37 degrees Celsius? Well, this right here is kilograms. So the mass they're giving me here is 200 kilograms. This right here, they're telling me the change. They're telling me delta T here because it's going from 25 to 37. So delta T is 12 degrees Celsius because 37 minus 25 equals 12. And now we need to know the specific heat. Let's go back a slide. C, this is the specific heat. For water, it is 4186. So, to find the specific heat of this, I'm going to use my equation. Q equals mc delta T. M is 200. C is 4186. And delta T is 12. What we get here is 10,046,400 joules of energy. Okay, let's look at our bottom one here. How much can 300,000 joules of energy? Well, this joules, that's telling me that this is going to be Q. 10 kilograms, that's going to be mass. Because they're using water, I can say that the specific heat is going to be 4186. How much can 300 joules of energy increase the temperature in a bathtub? So what they want us to find is delta T here. So Q equals mc delta T. The Q is 300,000. The mass is 10. The C is 4186. They want us to find delta T. When you divide this, the change in temperature you get is 7.2 degrees Celsius. Or you could say 7.2 Kelvin, because 1 degree change in Celsius is the same thing as 1 degree change in Kelvin. They have a one-to-one relationship. One of the things that's hard for students to keep in track is that this joules, when they're saying joules, they're giving you Q. The other thing they say quite often is they say how much heat. Well, heat is energy, which is joules, which means heat means also Q. Alright, I want you to work on this one. I'm going to give you a few bits. Alright, up here at the top, it says J, so that's Q. Right. Here, because it says kilograms, that's the mass. Here, they're telling you what C is. So you're going to put 234 in for C. So what are they asking you to find? Delta T. But once you find delta T, they're telling you that its initial temperature was 298. So what you're going to do to find the final temperature is you're going to take 298 plus that delta T, and that's going to give you your final answer. So first, find delta T. Second step, 298 plus delta T, and then you'll have your answer. Last bit of thing here. Alright, heat raises an object's temperature or changes the object's state. What we find out is that while a substance is melting or boiling, the temperature does not change. So right here at the bottom, we have this ice cube, and the temperature is going up because we're adding energy. But from here to here, we keep adding energy, but notice that the temperature doesn't go up. The temperature stays flat. Well, this is when it's talking about changing an object's state. This is when it's melting here. It's going from an ice cube to water. Notice it's water here, and here it's an ice cube. So even though we kept adding energy, the temperature didn't go up. Once it's all water, it will start heating up. here's the thing, once it gets to this point, 212, water can't get any hotter than 212 once it's in a liquid. So it's going to stay at 212 until all of the water is turned to, you guessed it, steam. Once it gets to steam, then it can start to increase in temperature again. But not until all the water has been boiled off. Well, hey, I hope that you learned something today. I'll catch you on the flip side.